So for problem A, we have to do g of x plus f of x. So all we are doing is substituting our values. We know that g of x is 2x plus 1. We know f of x is x squared plus 2x. Once you do that, then it's just a regular quadratic equation, and you just combine like terms and write it in standard form, which means these are like terms. If we put in standard form, it should go x squared plus 4x plus 1, and this would be g of x plus f of x. For B, we have g of x minus f of x, which means the same thing than this. And we're going to subtract. So we know our g function is 2x plus 1 minus whatever our f function is. We will have to subtract everything inside of it. And that is an x squared plus 2x. You're going to distribute that negative. And you're going to get 2x plus 1 minus x squared minus 2x. You're going to combine your like terms. Those reduce or go away, cancel. And you're going to write it in standard form. So this should be x squared plus 1. For part C, we have g of x times f of x. And we know our g function is 2x plus 1. Our f function is x squared plus 2x. You're going to double distribute. So that times that. So you should get 2x cubed plus 4x squared. This one times that one plus x squared. This one plus times that. It is 2x. You're going to combine your like terms and simplify. So you have 2x cubed plus 5x squared plus 2x. And then this is your final answer for C. For D, we have g of x divided by f of x. And we know our g function is 2x plus 1 divided by our f function, which is x squared plus 2x. Since there is nothing that I could factor out from the top and that I could factor out from the bottom that would reduce, this is your final answer. And lastly, we have E, which is g composed of f of x. For this function, you are basically saying, okay, my f of x function is x squared. So now I have g of x squared plus 2x, because now my f of x function is my new x. So this now becomes the x. Wherever I see an x in the g function, this is what you're going to substitute. You will be substituting this. So that means I'm going to have 2 times my new x plus 1, and my new x is this. So now it's x squared plus 2x. You're going to distribute, and you're going to have 2x squared plus 4x plus 1. And that should be your g composed of f of x equation or solution. So for A, we have that g composed of f of 2. So this right here, that 2 is our new x. So that means wherever I see an x in the f function, it becomes 2. So we have, then when we plug it in, so now we know f of x, sorry, not f of x now, because we know that that's going to be 2. So now we have 5, 2 squared minus 4. That's going to be 20 minus 4 is 16. So now we know that f of 2 is 16. But now that 16, wherever I see an x in the function, we're going to substitute that value, because now we have this. So we have 3 times 16, which is going to give us 48. I think in class, I did it where I did g composed of f of 2. and I was substituting things in there. So I had 3, and I knew that my new function, if for f, it was going to be 5 2 squared minus 4. If we simplify that, we're going to have 3, that should be 16, and it's still going to give us 48. Same way, different process. For b, we have f of g of 2, which now it's saying, well, wherever I see an x in my g function, now that's going to be 2. So our g function is 3x. So now we know that 3 times 2 is 6. So now we have f of 6, because we know this function, 3 times 2 is 6. Now wherever we see an x in the f function, we substitute that value. So we're going to have f of 6 squared minus 4. 5 times 36 minus 4. And we get 180 minus 4. And that becomes 176. And some of the similarities and difference that we talked for part C, similarities is basically it's the same process. They both share the same x value. Some differences is they have different answers. Your starting function is the opposite function, and so on. So for g composed of f of x that we have right here, we're going to identify our f of x. So our f of x function is the square root of x squared minus 4. Wherever we see an x in our g function, we're going to substitute that value in there. So that means that our g composed of f of x is going to be 1 over 3, and it's going to be times the square root of x squared minus 4. That would be our function or answer for A. For B, now it's going to be the reverse. Now we have f of g of x. So that means that we're going to, wherever this is our g function, wherever we see an x in the f function, that's going to go in there. So we are going to have the square root of our g function squared minus 4. We're going to simplify it, and we're going to have the square root of 9x squared minus 4. And we don't want a common denominator, so we're going to keep going and simplify it. So we need a common denominator, so we're going to have 1 minus, we're going to multiply top and bottom by 9x squared. And we're going to get 36x squared all over 9x squared. And then we could actually now simplify the bottom, because we know that this square root goes all the way to the bottom. So take the square root of the bottom term because it's a monomial. We cannot take the square root of 1 and negative 36x squared because of the minus sign. So if we simplify it again, we're going to have 1 minus 36x squared. All of that divided by 3x. And that is our function in simplified forms. C is asking us for the domain of f of g of x and g of f of x. So for our first function, our a, if we look at our function, which was this up here, we just need to look at our denominator, and we really need to look at what's inside of our square root. So that means we are looking at x squared minus 4 greater than or equal to 0. Oh wait, cannot be equal to 0. So let's erase that and just be greater, because it's in the denominator of our fraction. So we cannot divide it by 0. We're going to have x squared is greater than 4. Take the square root of both sides, and we're going to have x is greater than or equal to plus or minus 2. So that means it cannot be 2, and that cannot be a negative 2. So this is why we have this right here. So cannot be negative 2 and 2. We're going to find points in between and check. If we check, we're going to know that that's true, that's false, that's true. So that means that our domain is going to be x's of the reals such that x is going to be less than -2 and x is going to be greater than 2. For part B, we're going to look at two parts. We have to look at the inside of our square root, and we have to look at the bottom because we cannot divide it by 0. And this one has to be greater than or equal to 0. So we're going to have 3 cannot equal 0. So that means x cannot equal 0. That is one of our restrictions or conditions. Then we're going to have 1 minus 36x squared is greater than or equal to 0. Subtract the 1 to their side. Oops. And we're going to have -1. Divide both sides by -36. We're going to have x squared. Switch the sign to 1 over 36. Take the square root of both sides, and you're going to get that x has to be less than or equal to 1/6. Plus or minus, sorry. So we're going to have that our domain for this one is going to be x in the reals such that x has to be greater than or equal to -1/6. X has to be less than or equal to 1/6, and x cannot equal 0. And the reason we switched the equalities because I did my test points, but you guys already know how to do that, so you could do that on your own to check.